Hey everyone, and welcome. So, you've got C programming exams coming up, right? Well, you are in exactly the right place. Today, we're going to do a super focused session to make sure you master one-dimensional arrays so you can walk into that exam and handle any question they throw at you. All right, let's get into it. I want you to just picture your next exam. You open up the test booklet and bam, there's a chunk of C code staring right at you, and it's all about arrays. How does that feel? A little nervous? Well, by the end of this, you're going to feel totally confident because we are going to break down everything you need to know. We're going to start with the absolute fundamentals. And trust me, this is where most of the points on an exam are either won or lost. So let's get this right from the very beginning by tackling the what and the where of arrays. Now, this sounds like a really simple question, doesn't it? But getting the definition just right is so important. There are two key properties that define an array in C, and you can bet your professor is going to be looking for these two specific keywords. And here they are. First, every single thing in the array has to be of the same data type. So you can have an array of integers or an array of characters, but you can't mix and match. C just won't let you do it. Second, they're stored in a contiguous block of memory. All that really means is they're all lined up right next to each other, with no gaps in between. So this table really shows you what we mean by contiguous. Look at the memory addresses. If our integer array starts at address 1000, and we know an integer usually takes up 4 bytes of memory, then the very next element is guaranteed to be at 1004, and the next one at 1008, and so on. It's perfectly predictable. And that orderly layout is what makes arrays so fast and efficient. Here's a great way to picture it in your head. The whole row of mailboxes, that's your array. The fact that they're all connected shows that they're in contiguous memory. Each individual box has its own number on it. That's what we call the index. And the letter you put inside the box, that's your data, the element. Okay, now, for what is probably the #1 mistake beginners make in C. It's such an easy point to get on an exam if you just remember this one little rule. So, looking at our mailboxes, what number's on that very first box? Is it number 1? Nope. In C, we always start counting from 0. The very first element is at index 0, the second one is at index 1, which means for an array with 5 elements, the very last one is at index 4. Now, this isn't just a random rule. It's because the index is really an offset from the start. Index 0 just means 0 steps away from the beginning. So please burn this into your brain. C arrays are 0 indexed. All right, so now we know what an array is and where everything is located. The next logical question is, well, how do we get the data into those mailboxes in the first place? This section is all about initialization, and it's another goldmine for exam questions. This is the most straightforward way to do it. Let's just break this line of code down really quickly. Int tells us we're storing integers. Notlars is just the name of our array. The 5 tells the computer, hey, set aside enough space for exactly 5 integers. And finally, everything inside the curly braces just gets plopped into those 5 spots, in order. It's clean, simple, and you'll see it everywhere. And here comes a classic exam trick question. Let's say you tell the computer you want an array of size 5, but you only give it, say, 2 values. What happens? Does the program crash? Does it fill the other spots with random junk? What does C actually do? This is a super important detail for your exams. If you only partially initialize an array, C is actually really helpful. It automatically fills all the remaining spots with 0. It does not leave them with random garbage values. This is a predictable rule you can always rely on. And that leads us to a really important distinction. There's a huge difference between partial initialization and no initialization. If you just write int dizzy5, and that's it, those 5 spots in memory will be filled with garbage, which is literally just whatever leftover data was sitting in that part of the computer's memory. And that can lead to some really weird and unpredictable bugs in your code. So we've got our arrays, they're filled with our data. Now what? We need a good way to actually work with all that data, to go through it element by element. And for that job, the best tool we have is the loop. The combo of arrays and loops is really the heart and soul of array programming. Imagine you have an array with 100 student test scores, and you need to calculate the class average. You're not going to write 100 different lines of code, right? Of course not. You need an automatic, elegant way to visit every single one of those mailboxes, one after the other. And the for loop is absolutely perfect for this. Let's break it down into its 3 magic parts. First, int I equals 0. That creates our counter, I, and starts it at 0, our first index. Second, I is less than 5. That's the condition. The loop will keep on running as long as this statement is true. And third, I++. That adds 1 to I every time the loop finishes. This simple structure lets us step perfectly through our array from index 0 all the way to 4. All right, pop quiz time. Here is a very typical trace the code question you could easily see on an exam. Take a second, walk through that loop in your head. What's the final value of the variable toplam that gets printed out? This exact kind of problem shows up all the time. Did you get 45? If so, great job. Let's walk through it together. So the variable toplam starts out at 0. In the first loop, I is 0, so we add dizzy of 0, which is 5. Now toplam is 5. Next loop, I is 1, so we add dizzy of 1, which is 10. Now toplam is 15. The loop just keeps doing this, adding up all the numbers one by one until we get to the final answer of 45. Okay, so we've seen how to do things the right way, but for any exam, it's just as important to know how to spot when things go wrong. So let's look at the most common traps and mistakes with arrays that could cost you some serious points. Take a really close look at this code. We've got an array of size 5. The comment says we want to print the last element. But based on everything we just learned about 0 indexing, is dz5 actually the last element? What's the problem here? This is a classic out-of-bounds error. Sometimes people call it an off-by-1 error because our valid indexes are 0, 1, 2, 3, and 4. The index 5 just doesn't exist. It's outside the fence of our array. Trying to access it can crash your program or, even worse, give you really weird, unpredictable results. The real last element, of course, is at dizzy sub 4. And this mistake happens all the time inside of loops. On the left, see that condition I less than 5? That little equal sign is the bug. It's going to make the loop run 1 extra time and try to access that non-existent dizzy 5. The correct way, on the right, is to use I less than 5. That stops the loop right after I hits 4, which is our last valid index. That difference between less than and less than or equal to is absolutely crucial. So to wrap this all up, here's a little challenge for you. Using everything we've talked about, how would you write a program that actually reverses the elements in an array? You'd need a loop, for sure, but how would you swap the first element with the last one and the second with the second to last, and so on? Think about it. Maybe even sketch out the code. If you can solve that little puzzle, you are in fantastic shape for your exam. Good luck!